we're going to talk about covariance and independence. So we're going to deal with the concept of covariance like mainly in this video, and maybe in the next video we're going to talk about the independence of covariance and how it looks like when they're independent, to get prepared for proving the standard deviation of sample mean later, which was our third condition for getting the distribution of x bar, x mean. Yeah. So, okay. So let's see the definition of covariance first. So the definition of covariance looks like this when it's sample. But like when it's, we say it's population, we will use n instead of n minus 1. But most likely we're going to deal with samples a lot. So let's just write it down as n minus 1. Doesn't matter here actually. So yeah, anyway, this is the definition of covariance. And to get familiar with this, we need to see the variance of x or y. So it would be summation of x minus x bar. And the variance is like this when it's simple, but when to get more familiar with covariance and its concept, it's actually like this. Not good. So we can just see that instead of there's one more part of x minus x bar, like in covariance is y minus y bar here. So actually it's basically how it looks like, and we will get to see more about the features of covariance. So let's say this is actual data. I just made it, and this each point are data. So each has the x value and y value like this. So we can express it as a like x and y combination on the two-dimensional like screen. So let's take a look how covariance actually express and describe the relationship between the two variables x and y. So we can see x bar and y bar here. So let's just draw x bar and y bar. Like it would be something like x is from here and from here, and this is the mean of x bar would be somewhere like here, I guess. So here, let's just say it's x bar, and about y it would be from here to here, and it's kind of, it looks like well distributed. So let's say just like this is y bar. Okay, so it's better to take a look with one data point. So I like this one. So let's see with this one. So this data has a value of x, let's say x1, and a value of y1. So this x value is bigger than x bar, so this value would be plus, like have a positive value. And also about this value is bigger than y bar, so this also will have positive value. So positive value times positive value would be positive. So for this one, at least one data point, the this value would be positive. I'm not very interested in like what is the exact value of it is positive. And let's think about the other like data points here. So most of the data are located in this area and this area, and few here. So you can see that there's big difference, and also more dots, I mean data points in these two area, which are plus plus. So sorry, yeah, this is plus, because if there's a data here, is this data is smaller than x bar, so this value would be minus, and also about y value here is smaller than y bar, so it's also going to be a minus. So eventually it's about going to be plus. So when we say covariance and talk about the relationship between two variables, we can see that when there's more dots, more data points, and more gap to the mean of each variable, we can expect that the covariance, it would be positive value. So relationship would be like this, not exactly this line, but it would be something like this. So actually covariance is the start of a correlation, which is more useful uh, investigating the relationship between two variables. So this is actually how covariance works, and we can understand about covariance. Or if it's like this explanation is kind of confusing, you can just understand it with the concept of variance, the explanation that I introduced in the beginning of this video. So okay, this is the basic idea or concept of covariance, and let's take a look further in the next video.